So we have discussed the first law of thermodynamics in detail, and if I have to sum up the first law of thermodynamics, then I would mention two things. Basically, first, that it is basically a law of conservation of energy. That is one. And second, its mathematical expression is Q is equal to delta U plus W. The amount of heat given to a system is used up either in increasing the internal energy and or doing work. So this is what the second law of thermodynamics talks about. Basically, it's a law of conservation of energy. But this first law of thermodynamics has some limitations. It doesn't explain a few things. Let's look at them. Let me take an example. Let us say we have an object at 90 degrees Celsius and I bring it in contact with, let us say, another object. Let's say we have another object and I bring these two in contact and they are touching each other. Let us say they are in contact with each other, and this is at 20 degrees Celsius. What we know is heat transfer will happen from the object at higher temperature to the object at lower temperature. And law of conservation of energy will be valid in this case. The amount of heat which is lost by this would be equal to the amount of heat gained by this particular object. But let us for a moment imagine that it's possible for heat to go from this to this. Let us say this has got some amount of, it loses some amount of joules energy to this. And let us say heat is possible to move from the object at lower temperature to higher temperature. That means if this loses 20 joules of heat energy, this object would get 20 joules of heat energy. And the law of conservation of energy, that is the first law of thermodynamics, would be valid. But we know that this is not possible. So the first law of thermodynamics only says that this process is whether energy will be conserved or not. It doesn't say whether this process is not possible or not possible. In this case, it doesn't say whether that this process is not possible. It will only say that energy will be conserved. Let me take another example, and let us say we have a container in which we have some liquid and I have a stirrer in this. When I move this stirrer, I'm doing work, and this work is getting converted into heat energy. And as you can very well imagine, the amount of work which is done is getting completely converted into heat energy, and this conversion of work into heat energy is nearly 100%. But the question is the reverse process possible? That means conversion of Q into W. Is that 100%? Let us try to understand this with an example. Let us imagine the piston cylinder arrangement in case of a two-stroke engine. And let us say this is the spark plug which will ignite fuel and air mixture over here. And when it ignites it, this will expand and push this piston out. And this heat which is generated over here is doing work onto this piston. Q is to W. Now what is observed in real life is the energy conversion is not 100%. Quite a large amount of heat is lost in various ways. It is lost to the surroundings. It is absorbed by this surface. It is absorbed by the piston. And the energy which is over here, while it moves over here, some amount of energy is lost. And basically what we are saying is the amount of heat energy is not possible to completely convert into work. The conversion could be 60%, 50%, 40% or whatever. But complete conversion of heat energy into work is not possible. Again, if I apply first law of thermodynamics, it will say this process energy will be conserved. In this case also, the amount of heat energy which is there is getting converted into work energy, and it will add up all the losses and say first law of thermodynamics is valid or is not violated. But actually this process is not possible. It's not possible to convert Q into W completely, which the first law of thermodynamics doesn't mention or doesn't talk about. And hence we say these are the limitations of the first law of thermodynamics. And in this background, the second law of thermodynamics comes into the picture. The second law of thermodynamics has basically two statements, and we will discuss both of them one after the other. The first statement for the second law of thermodynamics is, which is known as the Clausius statement. It is impossible to transfer heat from a cold body to a hot body without expenditure of work by an external energy source. We talked about this example. It's not possible to transfer heat from an object at lower temperature to higher temperature in a spontaneous way, in a natural way. If we want to do this, if we want heat transfer from a colder object to a hotter object, we'll have to do external work. For example, in case of a refrigerator. So in the case of a refrigerator, heat is absorbed from the inside of a refrigerator where we keep the foodstuff. From there, heat is absorbed and it is given or passed on to the atmosphere, which is at a higher temperature. But for doing that, we have to use electrical energy. The electrical energy runs the compressor, it compresses the refrigerant, which absorbs heat from the foodstuff and then passes on the heat to the atmosphere. So external work is required. So what the second law says is that spontaneous process is from 90 to 20 degrees Celsius heat transfer, that is natural. But if you want to do the reverse, you have to do some amount of work. The another statement of Second Law of Thermodynamics, which is known as the Kelvin-Planck Statement, is this. It is impossible to convert all the heat extracted from a hot body to work. We discussed that over here. It's impossible to convert all the Q into it. Some amount of heat will always be lost. And these two statements of the second law of thermodynamics actually mean one and the same thing. They talk about whether a process is possible or not, whether a process will move from in one direction or not. So to summarize, the first law states that if a process takes place, the energy remains conserved. It does not tell us whether the process is possible or not. Okay, a final point on the second law of thermodynamics is that it cannot be proved directly. We don't have a direct proof of this, but the proof of this second law of thermodynamics is the fact that we have not been able to make a machine or an engine which contradicts second law of thermodynamics, and based on that we can say that second law of thermodynamics is valid. And all the deductions that we have made from this law after that we have found to agree with the actual or the practical results, and therefore we think that second law of thermodynamics is valid under all conditions. Okay, so that's a brief introduction to second law of thermodynamics. Coming up for discussion is our devices which apply second law of thermodynamics. We'll be looking at heat engine in detail and see how second law of thermodynamics is applied, and also heat pump wherein the reverse process happens. Thank you.